Good morning to everyone. Now we start to discuss about our project of data warehousing. So the first task of the project was the task relative to the inspection and profiling of the domain's data. At the beginning, we have chosen 9 business questions or hypotheses. To answer to this question, we have to perform an analysis on the data of the domain, that in this case are the data of Olympic Games. After we have explored some datasets about the Olympic Games on internet, especially on Kaggle website, and at the end of this inspection we have selected 4 datasets, and we have downloaded some tables from this dataset as CSV files. With the CSV files, we have started to the process of integration of the data. For integrating the different data sources, we have decided, in fact, to remove, for example, redundant and unuseful attributes or columns of the tables, and sometimes remove also an entire table. And sometimes we have also changed the name of columns for avoiding mismatching problem. And we have worked for do that in Tableau Prep, this application for preparing for modifying your data in the correct way, but also sometimes directly in the CSV file for fixing some mismatching problem.
So for the second part, it was about conceptual design. So we have made a dimensional fact model, which consists of fact Olympic event and 6 dimension, which answer specific question about the fact, which is year, event, host city, and athlete, games and medal. So games and medal we have considered it as a degenerate dimensions. Also, we have used yesterday or today configuration for our dynamicity of dimensions. So sometimes our hierarchical dimension attributes can change. For instance, changing the nationality of the athlete over time, and things like this. For the workload and data volume, we have made some calculation for data volume, as you can see, and we have calculated how many the size of the data for a fact model, for the fact, for the some attributes of the hierarchical dimension. Also for the workload, we have specified some aggregation pattern that was used in the queries for answering the business question, and you can see the example of the workload component, which is used for answering the first business question.
The third task was the task relative to the logical design according to the data warehousing process. So, for designing the logical schema, at first we have imported the CSV files with all the data, all the Olympics data, in the tables that we have created in PostgresSQL. The tables regarding the ER schema, the entity relationship schema. After this process, we have filled also the dimension tables and the primary and secondary fact tables. In PostgreSQL, the dimension and the fact tables were materialized view, with the data starting from the entity relationship tables. Okay, in this logical schema, we can see that the degenerate dimensions are represented directly in the fact table. This because The attribute year and medal, for example, are small in terms of space, and also they have different values. The games is not too small in terms of space, but is only one attribute, and so we have decided to not create the junk dimension tables. And we can see also that we have a nation dimension tables, and so this means that we have snowflaked in the nation attribute, the dimensional attribute, because the nation dimensional attribute is shared between the host city dimension table and athlete dimension table, and so we have to snowflake in this point. For this reason that the logical schema in question is a snowflake schema. The task number 4 is the task about the OLAP queries requested by the project assignment. At first we have wrote queries, SQL queries for creating the entity relationships tables, and after we have wrote queries instead for creating the materialized view, and so the dimension and fact tables regarding the dimensional fact model schema. After we have wrote the SQL queries, one query for each line of the workload, and so for answering to each business question. And on the other hand, we have wrote also query for answering the request in the project assignment using OLAP extension, so extension of the group by, and so the framing, ordering, and partitioning approach.
For the fifth task, which was about event Spark SQL, we have converted our OLAP queries to methods of the Spark structured API, which uses some methods like select, filter, and sort in this example. So it uses it needs a structured data, so we have converted our data to data frames and used these methods to convert our OLAP query to methods that was used in a Spark structured API, and it was used to answer one of our business questions. In the right part, you can see results of our query.
The final task of the project is the task relative to the Tableau report. Tableau is the Tableau Desktop is the software for doing this report. And we have retrieved 5 outcomes, 5 reports, but for a matter of times we are not able to explain in very well all the outcomes, and so we look in a fast way the report. The first report shows the correlation between the GDP per capita of the nation and the number of medal, and we can see that there isn't a real correlation if for the richest state and the number of medal. The second report shows the trend of the number of medals won by the United States over the year, over all the Olympic Games, Winter and Summer Olympic Games. The third report shows us the correlation between if a state that wins a lot of medals in the Summer Olympics wins a lot of medals also in the Winter Olympics, and in this case there isn't a real correlation, but we can see that the states that win few medals in the summer sometimes win very lot of medals in the Winter Olympics, for example the Nordic states. The report number 4 is a report that shows also another correlation between the population of a nation and the number of medals. And in this case also there isn't a correlation, so it's not true that a state with a higher population wins a lot of medals. The last report shows us instead the most successful sport for the Nordic country, and on the contrary of what we expected, there are only 2 countries that are winning in winter sport, and this is something strange.
Okay, so let's talk about some final considerations. So there was some problems that we had during the project. One of them was about Tableau Prep, which we have used to cleaning our data. So this application we have noted that it isn't intuitive for making the correspondent VLOOKUP functions on our CSV files, and we also couldn't find a method for inserting a primary key for each table. So for the hours of effort, we have spent about 50 hours for the whole project, and for the first task about 14 hours, second 12 hours, third like 8, and for the fourth it was like a 6 approximately, and for the last part we have required about 10 hours. We were working in teams with Eduardo for the project, and we were splitting our amount of work based on some engagements, some exams, and some personal appointments. So we were mainly contacting with a messenger, or sometimes we had meetings, and do everything in a shared directory in Google Drive. So about the amount of work that we have did, so Eduardo have done the first task, the second about the conceptual design, and the task 4. So it was checked and corrected by me, and the fifth task was done by me and checked by the Eduardo. The other task was designed together. So thank you for your attention. It's the end of our presentation.